Okay, welcome ladies and gentlemen to section 1.3. Finally moving forward here. Welcome back to all of this. Today we are going to be briefly touching on the 12 basic functions. For the most part, these are the functions that we're going to be dealing with a lot of throughout the course. And what I'm going to really point out today is the use of a piecewise function. These are somewhat important functions in math, and they always get stepped over every once in a while. So what I'm going to first do is just kind of briefly list out the 12 basic functions. On your page 102 and 103 of your textbook, you're going to have a picture of every single one of these graphs and their parent functions. And these are the 12 that this book feels are 12 basic functions. Now, there might be one or two that I feel is missing, but this is a good representation of our 12 basic functions. What you will notice on this particular list are, first of all, these three. These three are your normal three, your linear, quadratic, cubic. They're the first three in our polynomial set. They're the ones that we deal with more often than anything else outside of a cubic. You get your reciprocal function, which is just 1 over x. And if you're open to the page 102, 103, you'll know this. You'll see which function I'm talking about there. We have the square root function, the exponential function, which is either a growth or a decay. The words in parentheses are kind of like words you would use more often than not. Like the identity function is really just a linear function. The squaring function would be your quadratics. Cubing function would be your cubic. And you keep going down, you get the logarithm function. You get the sine and cosine function. Those are going to come up a little bit later when we learn how to graph those. We have our absolute value function. And the last two there are probably ones you've never seen before. The greatest integer function, in parentheses here, this first one is what it looks like on your calculator, INTX. You can actually graph it. And these are better known as step functions. You notice it steps up from one to another. It basically says, what is the greatest integer less than or equal to some number? So if I said INT of 3.1, the greatest integer is just 3, the biggest integer that's less than 3.1. And lastly, the logistic function. If you've had biology, you've seen the logistic function before. We deal with a little bit with it when we get to our exponential sections. So let's go ahead and move forward into, we're going to use these functions here and there, not today too much, but you'll have to be able to look at the graph and find domains and ranges of given functions. Let's get into piecewise. You may have remembered this from Algebra 2. A piecewise function is basically a function that's defined by two or more subfunctions. And each subfunction has a different interval from the entire function's domain. So here's an example. F of x equals x plus 2, and f of x equals x minus 2 quantities squared. If you look at the first part of this equation, this tells me that x plus 2 only exists when x is less than 2. And the x minus 2 squared only exists when x is greater than or equal to 2. So if we were going to sketch a graph of what this function would look like, here's what we're going to have. If I look at the value of 2, since that's kind of where things are changing, if we were to think about, okay, what does x plus 2 look like? Well, x plus 2 looks like a y-intercept of 2. And notice we're looking at the left side of 2, because right here is 2, but this is less than 2, and this is greater than 2. So we're looking to the left side of 2. I'm going to write that here. Left side. And the left side of positive 2 says, okay, y-intercept of 2, slope of 1, going this direction, and then slope of 1 continuing on. Now here's where the thing gets iffy. When x equals 2, that does not exist for this line. So we're going to put an open dot right there. And then we're going to connect. We're going to stop. And you notice that everything on this line is x plus 2, but we're only dealing with it when x is less than 2. Okay, so for the other side of 2, and when x is 2, it's part of this line. So let's plug in 2. If we plug in 2, we get 2 minus 2 is 0. Squared is 0. So that means that's right there. And if you recall your algebra 2, that is your vertex of your quadratic. It's shifted 2 units to the right. And then we could just use all the points to the right of 2. So if I plugged in a 3, I would get 1. And if I plugged in a 4, I would get 4. If I could do my math right. And then going from the right-hand side of 2, this is what this looks like. This is the graph of f of x. Not this little dash. That was a typo. Okay. Let's look at another one. A little bit more complicated one. Let's go example 3 first, then we'll go back to example 2. So we look at here and we say, okay, it's x squared when x is less than or equal to 0. It's 2 between 0 and 2. And it's x minus 2 when x is bigger than or equal to 2. So let's see what that looks like. So big things are happening when x is 0 and when x is 2. All right, so when x is less than or equal to 0, okay, so when x is 0, I can plug it in there. So I get 0, plugging in 0 into this function here. And I want to go left of 0, which is less than 0, right? So left of 0, if I go left 1, I'm going to go up 1. And if I go left 2, I go up 4. And it's basically just plugging in the values, folks. And we get that part of the parabola being an x squared function. Okay, so the next is, okay, what's happening between 0 and 2? Well, it's the line y equals 2, which is horizontal. So at 2, or at x equals 0, it's 2, but it can't be a filled dot because that would not be a function. And then it's horizontal all the way until 2, but because it's not equal to 2, it's an open dot. Then we start at x equals 2 for x minus 2. Okay, so if we plug in x equals 2, we get 2 minus 2 is 0. That's where our open dot's going to be. And if we go to the right, that's just a slope of 1. So we go up 1, right 1, or sorry, up 1, right 1. Oops. Oh, man. Stupid glitch. Okay, let's try that again. Sorry about that. So this is the quadratic piece. I'm not a very good grapher on this computer here. We go from 0 to 2, where it's a horizontal line at 2. And then we had that point 0, what I was about to do here, slope of 1, and we go up 1, right 1, up 1, right 1, and we go like so. And there we go, we have this g of x function here. Now I could ask a few other questions here. I could say, what is g of 3? Well, I don't just randomly plug it into anything that I so choose. I say, okay, well, 3 only exists in this interval, and therefore I'm going to use this function. So g of 3 is equal to 3 minus 2, which is 1. So we should have the point 3, comma 1 on our graph, and yes, we do. It's right there, 3, comma 1. I could do things like, hey, what is g of 0? Well, I need to look. Where does 0 exist in the intervals? 0 exists here, and therefore I'm going to plug it into this function. So I get 0 is 0 squared, which is 0. And sure enough, we get the point 0, 0. Okay, let's see what this one looks like. This one's the hard one. Kind of follow along. Some of this is not going to look familiar to you, especially depending on how much you remember how to graph absolute value functions and square root functions. We'll get to those. Okay, so the absolute value function being less than 0. So we got a lot of stuff going on at 0 and at 4. So it's really only two numbers that we're dealing with here. So when we're going less than 0, we are at this absolute value function. Now, if you recall from absolute values, the vertex, remember absolute value is a V shape. The vertex is whatever makes the absolute value 0. So that's negative 2, comma 1, the stuff on the outside. So at the point negative 2, 1, that's your vertex. And then on either side of that vertex, it's the slope of the piece on the inside. So the slope is 1. So I'm going to go right 1, up 1, and right 1, up 1. But I'm going to have to open dot because it does not exist at x equals 0. And I'm going to do the same thing on the other side. So this 1 slope is what I'm dealing with. There we have our absolute value, starting at negative infinity and ending at 0. But then it tells me when x is 0, it tells me y is negative 2. Okay, so when x is 0, y is negative 2. So that's just the coordinate 0, negative 2. So I get a closed dot right there. Then I have negative quantity x minus 3. Well, if you rewrite that, that's just negative x plus 3, which is a linear function that says, hey, start up here at 3 and go a slope of negative 1 all the way to 4. Okay, that's pretty easy. If I start here, well, that's an open dot again because it's not equal to 0. And I'm going to go down 1, right 1, down 1, right 1, down, right, and down and right 1. And it's not equal to 4, so I have to put an open dot right there, and I'm going to connect like so. That should be a straight line. And then the last one is the negative radical of x minus 4. Now, depending on what you remember from Algebra 2, we're going to learn this a little bit more a little bit later in this chapter, but that minus 4 tells me go right 4 units. And if you looked at page 102, you'll see that the square root function looks like this. So if I go right 4 units, it's going to go like this. But that negative tells me to flip it over the y-axis, or the x-axis, so it's going to go like that. So over at 4, I move to the right 4, and instead of going up and to the right, it's going to go down and to the right. So it looks something like that. Pretty interesting little function. I can ask all sorts of questions like, hey, what is h of 0? Well, it tells me. I need to look for it. Okay, well, h is 0, x is 0 right there, so that's negative 2. I can say, hey, what is h of let's go h of 13. Well, h of 13 occurs in this interval. 13 minus 4 is 9. Square root of 9 is 3, but it's a negative, and therefore it's negative 3. And it should be out here somewhere out at 13. It should be at negative 3. Okay, so this was a very brief lesson. Really kind of pay attention to those 12 basic functions. Learn a little bit how to graph piecewise functions. They creep back up on you in calculus when you get there. And here's your assignment. Have a good evening. I will see you guys tomorrow.